Hi everyone, this is Dr. Nuck, and today we're going to be learning about the properties of logarithms. You're going to have to memorize a few properties, so you might want to write everything out on a piece of paper or use the flashcard or do whatever it works the best for you. Let's just get straight into this. Alright, here they are. Here are all the properties of the logs that you must memorize. So grab a piece of paper or a flashcard and write down all these properties. Alright, so let's go through this chart. So the first one, the properties of log. Let's first go with the base A and then go with base E. Alright, so the properties of the log says log base A of 1 is 0. Now remember that ln is nothing but a log base E. So the ln must have the same exact property. So that means that ln of 1 must be 0, again because ln is same thing as log base E. So I'm going to call that property 1. Now property number 2, log base A of A equals to 1. So with that said, ln of E must equal to 1. And let's go with property number 3. Do not panic. So the first one is a to the log base A of x. It's going to equal to x. And log base A of A to the x just becomes x. So basically, this is how I used to memorize it. If the big base and a little base are the same, they sort of cancels each other out. So for the first one, if you got a to the log base A of x, then do you see that we got the little a and a big A, they matches up, so they're going to cancel each other out. So what you're going to get is just the argument of the log, which is x. And for the second one, if you got a log base A of A to the x, again, little base and then big base matches up, so they're going to cancel each other out, and the result is just the exponent on the argument of A, so which is just x. And same thing's going to happen with ln. So we got e to the ln of x equals to x, and then ln of e to the x equals to x. So you can think of it as e and ln. They're going to cancel each other out. Now let's call this one property number 4. If we got a log base A of m times n, it's going to become log base A of m plus log base A of n. So if you got a product, it's going to turn into an addition. Now same thing for the ln. We got ln of m times n. It's going to be ln of m plus ln of n. Alright, now let's go with property number 5. So we got a log base A of m over n. So we got a division going on. Now what's going to happen is that that's going to equal to log base A of m and then minus log base A of n. So the division becomes a subtraction. And same thing for ln. So if you got a ln of m over n, that's going to be ln of m minus the ln of n. And the last one is the power property. So if you got a log base A of m to the p, that little p is an exponent on m, you can bring that exponent in front of the log. So we got log base A of m to the p equals p times log base A of m. Now same thing with the natural log ln. So we got ln of m to the pth power is bring that p in the front of the ln, and you got p ln of m. The next property is a change of base formula. Now this formula is super duper useful because if you look at your calculator, you should only see a button which says ln or just log. Remember, if it's just log, there is a little base 10 sitting there. So there are no key buttons for log base 2 or like log base 5 or anything like that. So what I'm trying to say is that suppose you have to compute something like log base 2 of 5 or something like that. Well, you cannot use your calculator to compute this because there is no log base 2 button. But this is telling you that if you apply the change of formula, you can pick any base that you want. So here, what we're going to get is log, if you want to just do log base 10, so So it's going to be just log of m. So m is the argument, so which is 5, all over log of the little base, which is 2. Now you can compute this in your calculator. So I'm going to say can use the calculator. And then this one cannot. Alright, now same thing for ln. You can pick and choose whatever base that you want, but now if you take a look at like maybe log base, let's take a look at the same thing. Log base 2 of 5, well, you can change this into a ln as well. So this is same thing as, remember, because ln is same thing as log base e, isn't it? So basically I'm changing log base 2 of 5 in terms of log base e, which is ln. So this is same thing as ln of 5 over ln of 2. Now you do have those ln key on your calculator, so from here we can use the calculator. But this guy cannot. So this is the reason why change of base formula is pretty cool and pretty darn important. Anyways, the best way to learn how to use the properties of the log is doing a bunch of examples. So let's get started. Alright, example 1, evaluate using the properties of log. Part A, log base 13 of 1. So if you wrote all the properties down on a piece of paper or flashcard, get those out and then use those until you get a hang of it. But anyways, let's go with log base 13 of 1. What will be the answer? Which property can we use? Can we not use property number 1? Remember, the property number 1 says that log base a of 1 is always going to be 0, no matter what the base a is. So in this case, our answer is going to be just 0. Now let's look at part B, log base 8 of 8. Alright, so take a look at your notes. Which property? Well, can we not use this one? Log base a of a equals to just 1. Alright, so in this case, if the little base and then the big base matches up, your answer is just going to be the exponent on the argument of the log. Now remember, there is an invisible 1 sitting on top of this 8. Alright, so this answer is going to be just 1. Now let's go over something like 4 to the log base 4 of 13. Alright, so notice that again, we got the big base and a little base matches up. So like I was mumbling earlier, you can think of it as they cancel each other out, and what you're going to get back is just the argument of the log, so which is going to be 13. But if I have to write down the property that I'm using, this will be a to the log base a of x. This is just going to become x. Alright, so in this case, our answer is going to be 13. Part D, log base 5 of 5 squared. So here, again, do you see that the little base and big base matches up? So you can think of it as they cancel each other out. So what's left? Just 2. Okay, so this answer is going to be 2, but let me write down the properties that we're using. So this is same thing as log base a of a to the x equals to x. So our answer is going to be 2. Alright, now let's take a look at example 2. Use the product property of log to write each log as a sum of logs. Simplify. So basically what we're looking at is to be using this formula. So if you got a log base a of m times n, this is going to be log base a of m plus the log base a of n. Okay, so let's take a look at part A. log base 4 of 64x. So here, do you see that 64 plays the role of m, and then our x plays the role of n. So what we need to do is we're going to expand this by using the formula above, so which is going to be log base 4 of 64, and then plus the log base 4 of x. Now, since we're going to have to simplify all the way, let's take a look at log base 4 of 64. All right, so do you see that 64? Can I write 64 in terms of base 4? I think so. Isn't it 4 to the third? Isn't it 64? So what I'm going to do is I'm going to rewrite the log base 4 of 64 as log base 4 of 4 to the third, and then I'm gonna just drop down the log base 4 of x. There's nothing that you can do to log base 4 of x. Alright, so now let's take a look at the log base 4 of 4 to the third. Can I simplify that? I think we can. So again, if the little base 4 and the big base 4 matches up, what's left with is just the exponent. So in this case, this is same thing as just 3 plus the log base 4 of x. And that's going to be the answer. Now let's try something like log base 3 of 27xy. So here we got something of the form m times n times l or something like that. But anyways, so if I use the properties that's written above, this is our first step. Log base 3 of 27, and then plus log base 3 of x, and then plus log base 3 of y. Alright, the first step is done. Now, log base 3 of x and log base 3 of y, there's nothing else that we can do. So let's just leave it alone, and let's take a look at log base 3 of 27. So since the little base is 3, you should be asking yourself, okay, alright, is there any way that I can write 27 in terms of base 3? I think so, because isn't 3 to the third? Isn't that same thing as 27? Hence, we can go one more step. So this is same thing as log base 3 of 3 to the third plus log base 3 of x, and then plus the log base 3 of y. So again, oh my goodness, there's so many 3's flying around, but log base 3 of 3 to the third, the answer is just the exponent. So here you're gonna have that 3 is over here, and then plus log base 3 of x, and then plus the log base 3 of y. And that's gonna be our answer. Alright, now let's take a look at something like this. Log of 1000x. Do not panic. Alright, so first let's expand this out by turning this into an addition. So here you're going to have log of 1000, then plus log of x. Alright, now let's stare at that 1000. Now remember, if there is no base written down under the log, that means there is a base 10 sitting here. Alright, so let's see. Can I write 1000 in terms of base 10? I think so. Isn't it to the third power? So I'm going to rewrite this as log of 10 to the third, and then plus log of x. So here you're going to have 3 plus log of x. And that's it. Okay, now let's take a look at something like this. Expand the log. Okay, so we got the quotient going on here. So let me just write down the property. So log base a of m over n, that's log base a of m minus log base a of n. So this is the key formula that we're going to follow right now. So ready? So this is same thing as log base 5 of 125, and then minus log base 5 of x. All right, so now let's take a look at 125. Is there any way that I can write 125 in terms of base 5? Yup. So 125 is 5 to the third. So I'm going to use that to rewrite this as log base 5 of 5 to the third minus the log base 5 of x. So this is going to be just 3 minus log base 5 of x. And I think this is going to be our answer. Now let's take a look at log base 6 of 5 over 6. So again, I'm going to expand this by using that formula that we wrote above. So this is log base 6 of 5 minus the log base 6 of 6. Alright, so I don't think we can do much with the log base 6 of 5, so I'm just going to leave it the way it is. Alright, now let's take a look at log base 6 of 6. Okay, so do you remember this property? If you have a log base a of a to the x, this just becomes x. But in this case, remember that there is that invisible 1 sitting on top of the argument of 6. So in this case, log base 6 of 6 just becomes 1. So this is going to be the answer. I don't think we have played with natural log yet, so let's do a couple of examples involving the natural log. Part C, ln of e to the third over 3. Now remember, ln has the exact same property as logs because, again, ln is nothing but log base e. So let's get started on this one. So here, I could rewrite this as ln of e to the third minus ln of 3. Now remember, ln of 3 is just some kind of a decimal value, so it's a constant, so just leave it alone. And then let's take a look at ln of e to the third. Okay, so do you remember this property? ln of e to the x, this is just x. So you can think of it as ln and e, they kill each other. So what's left over is just that exponent. So here what we're going to get is 3 and then minus the ln of 3. And that is going to be the answer. Alright, example 4, expand the log. So let's take a look at something like ln of 4 times x to the 6 times y squared. You ready to do this? So again, I'm going to write down all the properties that we're going to be using. So ln of m times n, this is same thing as ln of m plus the ln of n. Alright, so let me just first apply that. So here you're going to have ln of 4 plus ln of x to the 6 plus ln of y squared. Now ln of 4 is some kind of a decimal value number, so it's just a constant, so leave it alone. But now let's take a look at ln of x to the 6 and then ln of y squared. Alright, remember this property, we're going to have to go one more step. ln of m to the p, remember what happens to the exponent? Yes, it goes in the front of ln, so you're going to have p times ln of m. So that's the property that we're going to use for the last two terms. So here we're going to get ln of 4 and then plus 6 times the ln of x and then plus 2 times the ln of y. Okay, I think that's pretty much it. So that is our answer. Now let's take a look at log base 5 of 4th root of 21 times y to the third. Okay, so let's take one step at a time. So first what I'm going to use is log base a of m times n. It's log base a of m plus the log base a of n. Okay, so first step will be log base 5 of 4th root of 21, and then plus the log base 5 of y to the third. Okay, so now let's go into the next step. So remember that 4th root is same thing as 1/4 power. So I'm going to rewrite this as log base 5 of 21 to the 1/4, and then plus the log base 5 of y to the third. Okay, so again, we could apply that exponent property. So again, if I have a log base a of m to the p, this is p times log base a of m. So let's bring that exponent out in the front of the log to get 1/4 log base 5 of 21, and then plus 3 times the log base 5 of y. And that's it. Let's take a look at another one. Part C, let's try something like log base 3 of square root of 3x plus 2y squared all over 5z squared. All right, do not panic. Take one step at a time. So first property that I'm going to use is log base a of m over n. This is log base a of m minus the log base a of n. So let me just split that up real quick. So here you're gonna get log base 3 of square root of 3x plus 2y squared, and then minus the log base 3 of 5z squared. Alright, so that is going to be our first step. Now every time you see a square root or cube root or 4th root, make sure to rewrite that in terms of an exponent. So here what I'm going to do is I'm going to rewrite the square root as a power of 1/2. So you're going to have log base 3 of 3x plus 2y squared to the 1/2 power. And then minus, now let's take a look at this portion, the second portion here. Now be careful, there's a minus sign out in the front. All right, and then furthermore, remember log base a of m times n is the log base a of m plus the log base, oh no, I'm running out of room, log base a of n. All right, so that is the property that I'm going to apply, but be careful because of that minus sign. So what you need to do is you have to put a bracket here. All right, then you expand. So here you're gonna have a bracket, log base 3 of 5 plus the log base 3 of z squared, and bracket closed. Okay, so that means that you're gonna have to distribute the negative sign to each term in the bracket. So now let's go one more step. So let's use that exponent property. I could bring this 1/2 out in the front. So here you're gonna get 1/2 log base 3 of 3x plus 2y squared, and then here you're gonna get minus log base 3 of 5 and minus log base 3 of z squared. It's gonna become minus because what I did was I just distributed this negative to each term. All right, so now let's simplify a little bit more. So the first one, be careful here. A lot of students think that I could split this guy up into log base 3 of 3x plus the log base 3 of 2y squared. That is an illegal math. That's an illegal maneuver there. Okay, so I'm going to write it in red so you don't do this. So note, log base 3 of 3x plus 2y squared, this does not equal to log base 3 of 3x and then plus the log base 3 of 2y squared. All right, so only time you're gonna make that into an addition in between is if the 3x and 2y are multiplied together, not the addition. So please keep this in mind because this is a common mistake that I see. every semester, I should say. All right, now let's keep going. So pretty much you cannot do anything to the first term. So I'm just going to leave it as 1/2 log base 3 of 3x plus 2y squared. And then minus, can I simplify log base 3 of 5? No, because there is no way that I can write 5 in terms of base 3. So I'm just going to leave it the way it is. And then what about the last one? I think I could still bring that exponent out in the front. So here what we're going to get is minus 2 times the log base 3 of z. So this is going to be our final answer. How are you guys doing up to here? I know that it's kind of getting nastier, but you can do this. So let's do another one. And the next one, what I want you to do is try the problem on your own. So here it is. Log base 2 of 4th root of 5x to the 3rd over 2y squared z to the 4th. All right, pause the video and try this on your own. And I'm gonna assume that you paused it and tried it, so let's get to work. Now there are a couple ways that you can do this, actually a few ways I could say, but the easiest way would be that first convert that 4th root into an exponent of 1/4 in the parentheses. So this is what I would do. Log base 2 of 5x to the 3rd over 2y squared z to the 4th, that's a 4th, or sorry, to the 1/4. Okay, so now what? Yep, that exponent 1/4 goes in the front of the log. So this is going to be 1/4 times the log base 2 of 5x to the 3rd over 2y squared and then z to the 4th. Okay, looking good. So now I'm going to work on this portion. Now this is going to be 1/4. Be careful, you need a bracket here. Make sure to put a bracket. Okay, so here what you're going to get is log base 2 of 5x to the 3rd and then minus the log base 2 of 2y squared z to the 4th, bracket closed, which means that you need to distribute the 1/4 to each term at the end. Okay, so now let's keep going. I'm going to drop down the 1/4, keeping that bracket. Now let's work on log base 2 of 5x to the 3rd. So what did you guys do here? Did you split it up with a plus sign in the middle? I hope so. So this is going to be log base 2 of 5 and then plus the log base 2 of x to the 3rd. And then, oh, this is going to be a little tricky here. Now you're going to have to deal with the minus sign there. So you're going to have minus, be careful. When you expand that 2y squared z to the 4th, you still have a minus sign in front of it. So here you're going to have to put another bracket. So let me just make this one a little bit fatter. For the first bracket, I'm writing it a little bit fatter. And then the second bracket, here we go. Ready? So what we're going to be doing is we're going to be working here. All right, then what we're going to get is log base 2 of 2 plus the log base 2 of y squared and then plus the log base 2 of z to the 4th, bracket closed, and then the fat bracket closed. All right, now let's keep going. So what I'm going to do now is let's just apply the exponent property if we can, and then distribute that minus sign. So now we got log base 2 of 5, and then plus, I could bring this 3 out in the front of the log. Then you're going to have 3 times the log base 2 of x. Now let me distribute that minus sign to here, here, and then to here. Okay, so then what we're going to get is minus log base 2 of 2. Aha, we could still simplify that. And then let's bring this exponent 2 on the front of the log. And then you're going to have, oh, minus, sorry, it's not plus. I'm distributing the minus sign in each term. So you're going to have a minus 2 times log base 2 of y. And then minus 4 times log base 2 of z. Bracket closed. All right. Oh my goodness. We got this. Okay, so this is same thing as 1/4 times. Okay, can I simplify log base 2 of 5? No, because I cannot write 5 in terms of base 2. So leave it alone. And then 3 log base 2 of x. You can't do anything to that, so leave it alone. All right, now let's talk about log base 2 of 2. Do you remember what that's going to be? It's 1. So this is going to be 1. And then minus 2 log base 2 of y. Can't do much to it, so I'm just going to leave it alone. And then similarly for the last term, 4 log base 2 of z. Bracket closed. Oh my gosh. All right, I think that's pretty good. If you want to distribute the 1/4 to each term, go for it. Or you can just leave it out in front of it. But make sure to distribute all the negative signs and simplify all the way. But anyways, you know what? Just in case, I'm just going to distribute the 1/4. So you're going to have 1/4 log base 2 of 5 plus 1/4 times 3, so that's 3/4 log base 2 of x, and then minus 1/4, and then minus 1/4 times 2, that's 1/2 log base 2 of y, and then minus 1/4 times 4 is 1, so I'm just going to keep it as minus 1, and then log base 2 of z. Alrighty then, so that is going to be our answer. Alright, if you got this one right, you are in pretty darn good shape. I am hoping that you're kind of getting used to this, because now what we're going to do is we're going to work backwards. Instead of expanding the log, we're going to be condensing it. So let's try something pretty simple. Condense the logs. So part A, log of 4 plus log of 25. Okay, so now let's recall that log of m times n is log of m, and then plus the log of n, right? So what we need to do is we're going to have to multiply the two arguments together. So this becomes just log of 4 times the 25, which is log of 100. All right, so now I think we need to go one more step, because remember, if there is no little base, that means that there is a base 10. And you should be able to write 100 by using base 10. So now I'm going to rewrite it as log, or if you want to put 10 there, that's fine, of 100 is 10 squared. So our answer is going to be just 2. Alright, now let's try something like this. Log base 3 of 36 minus log base 3 of 4. So let me just write down the property again. Log of m over n is log of m minus log of n. So what we're going to do is to condense this into a 1 log, we're going to have to use that quotient property. So here you're going to get log base 3 of 36 over 4. So, which is same thing as log base 3 of 9. Alright, now can we write 9 in terms of base 3? Oh heck yeah, so this is going to be log base 3 of 3 squared. Now what's going to happen? Since the little base 3 and the big base 3 matches up, they're going to kill each other. So our answer is just the exponent on the 3, which is just 2. So this is going to be our answer. Part C, log base 7 of 3 plus log base 7 of x minus the log base 7 of y. All right, do not panic. Just take one step at a time. Work from left to right. So first, what I'm going to do is I'm going to combine these two together. So here what we're going to get is log base 7 of what? Yes, 3 times x. And then I'm going to drop down the minus the log base 7 of y. All right, now what? Since we have a minus sign in the middle, it becomes a quotient, doesn't it? So this is same thing as log base 7 of 3x over y. Now, I don't think we can simplify 3x over y any longer, so guess what? That's going to be the answer. How about you try this one? Part D, 6 log base 3 of x plus 9 times the log base 3 of y. So pause the video and try this problem on your own. You might have to use that exponent property though, right? I don't know why I keep pausing every time. All right, so I'm gonna pretend that you did this problem, so let's get started. So first of all, remember this one, log base a of m to the p, that's p times log base a of m. All right, so let's do it. So this is gonna be same thing as log base 3 of, now remember, this becomes the exponent on the argument here. Okay, so then here you're gonna have x to the 6, and then plus, now the same thing, this 9 becomes the exponent on the y. So here you're gonna get log base 3 of y to the 9th power. So far so good. All right, now we could still condense this into a 1 log by using, oops, let me just write everything out, sorry. Log base a of m plus the log base a of n is log base a of m times n. So I'm going to use that property to shrink it up. So this is log base 3 of x to the 6 and then y to the 9. I think this is as far as we can go, so I'm going to box this for the answer. If you made a mistake somewhere, do not get discouraged. Just find where you went wrong. That's the most important part of learning. So let's just try another one. Let's try log base 3 of x squared minus 1 minus 2 times the log base 3 of x minus 1. So take one step at a time. So first I'm going to use is this property, log base a of m minus the log base a of n equals log base a of m over n. But first, I guess I can apply the exponent property for the second term. So here, let's go. Ready? So this is going to be log base 3 of x squared minus 1. Then what I'm going to do is I'm going to rewrite this by using the exponent property. I'm going to have minus log base 3 of x minus 1 squared. So far so good. All right, now let's keep going. So here what we're going to get now is, let's just combine these two together now. Here we're going to get log base 3 of x squared minus 1 over x minus 1 whole thing squared. All right, now we got to go a couple more steps. Remember this difference of two squares, a squared minus b squared. This is a plus b and then a minus b. So I'm going to factor the numerator by using the difference of two squares. So here you're going to get log base 3 of x plus 1 and then x minus 1 all over. Now x minus 1 whole quantity squared is x minus 1 times the x minus 1. All right, so that's what I wrote. Now do you see that we could still simplify a little bit? So we can get rid of the one term of the x minus 1s to get log base 3 of x plus 1 over x minus 1. And this is going to be the answer. So let me just box that. All right, now let me show you another illegal math. Okay, so I know that it's so tempting. If you have something like x plus 1 over x minus 1, you so want to cancel out that x, but you cannot. Only time you can cancel the x's from the top and the bottom is if everything's being multiplied. Here, x and a 1 are separated by plus and a minus. So you cannot just kill that x. All right, for example 6, let's take a look at problems like use the change of base formula, rounding to 3 decimal places to approximate each log. So problems like this, please get your trusty calculator out because we're going to have to compute this by using our calculator. All right, so first let's go with the change of base formula. Just going to write it over here. Change of base formula says log base a of anything, maybe just go m. This is same thing as log base, I don't know, b of m over log base b of a. Now, b can be any number. Okay, so b is any number. But the thing is, remember on your calculator, you only are given base 10 and base e. So what you want to do is you're always going to want to take the b to be either 10 or e. Anyways, let's follow the formula to simplify this a little bit. So this, I can rewrite it in terms of a log base 10. This is same thing as log of 46, whole thing over log of 5. Oh yes, another thing is this. Let me just show you the illegal math. Okay, I see this all the time, and I see why a lot of students do this because I used to do the same thing. So please note, I'm going to write something that is completely illegal. So note that log of 46 over the log of 5, this does not equal to log of 46 over 5, by the way. So be careful, they're not equal to each other. Alright, anyways, let's keep going. So now you're going to have to bust out your trusty calculator to compute log of 46 over log of 5. So I just used my calculator, and this is approximately 2.378868. This is good enough, and the question saying rounding to 3 decimal places, so I'm going to round it off here, and this is going to be what, approximately 2.379. So that will be our answer. Now make sure that you are in radian mode, not in the degree mode if you have a graphing calculator. If you're in a degree mode, it will give you a completely different value. So make sure that you are in radian mode. Alright, let's take a look at part B. Log base square root of 3 of 21. Okay, if you want to try this on your own, go for it. And let's compare our answers together. So pause the video and use your trusty calculator to compute that value. Alright, so let's see what you got. Now, since we used log, what I'm going to do for this problem is I'm going to use the natural log because I can change that base into a base e, which becomes a natural log. So your answer will be the same if it's log or ln, by the way. So I'm going to rewrite this as ln of 21 over ln of the square root of 3. So if I use my calculator, I got this value to be 5.5424. So I'm just going to leave it as 5.542. So I'm going to box that for the answer. Now, if you use log, that's totally fine, because look, if I'm gonna go, let's do the same problem by using the log base 10 key. So you can rewrite this as what? Log of 21 over log of square root of 3. So type that in the calculator and see what you get. And you should get the same answer, 5.542. So again, change of base formula is pretty darn cool, because no matter what base that you're going to change into, your answer will still be the same and you can use your calculator. So I'm going to stop here. So if you have any questions at all, please let me know. And again, great job everyone, and keep up the good work.